Okay, this is Geometry, Chapter 8, Section 4, Angle of Elevation and Depression. Alright, so angle of elevation. So you look at this picture. We have a young lady. I'll draw him as a stick figure if you don't mind. Looking at some line of sight. The ground has to be sort of parallel. So it says they're a horizontal line. So it has to be parallel. Looking at a glider. So, alright, so she's looking up on that. And this also has a horizontal line of sight. So it has to, these guys have to be parallel lines for this to work. Otherwise, it wouldn't be angle of depression. So these horizontal line of sights are basically parallel lines, and this line is sort of like the a transversal, like a hypotenuse, and the angle of elevation would be right here. In this case, they had it at 38 degrees. So angle of elevation is the angle at which this person is looking up at an object that's going in a horizontal distance while this person is standing in a horizontal distance. Here, that same 38 degrees, since it's a parallel line, and this is a transversal, this is basically alternating interior angles. And the line of sight of, or the angle of the depression, or looking down upon an object, that's called an angle of depression. All right, so we have angle of elevation, angle of depression. Angle of elevation, you're looking up at an object. Angle of depression, you're looking down at an object while those two objects are going in parallel directions, essentially alternating interior angles. And according to the book, the angle the person on the ground sees a hang glider above the horizontal horizon, angle of elevation. At the same time, the person passing down sees the ground, that's the angle of depression. So, angle looking up, angle of elevation, angle looking down, angle of depression. So we have this diagram right here. Of a person on a balloon looking up at stuff and looking down at stuff. Person. Again, here's this person's horizontal line of sight. Here's this person at the ground. I guess there's like a mountain top. And there's some bird, which also has a horizontal line of sight. Alright, so the angle which the bird looks down upon the balloon, that's an angle of depression here. The angle at which the balloon looks on the bird, that's the angle of elevation. And here, number 3, the angle at which the person looks down on the ground of the hill is a depression. And then the vantage point of the hill looking up at the balloon, that's angle of elevation. So they're asking, yeah, what it is. So for angle 2, Angle 2 is elevation. So let's start from the beginning. So angle 1, we're looking from the vantage point of the bird. The bird is looking down. So angle 1, I'm going to say angle of depression. So I'll just put AOD. Angle 2, the person is looking up at the bird. It forms an alternate interior angle with angle 1. So if angle 1 is angle of depression, then angle 2 is angle of elevation. And then number 3, that person is looking down onto the base of the mountain. So that's angle of depression. And then angle 4, the base of the mountain looking up onto the of the balloon, and its alternate interior angles with angle 3. So angle 4 is angle of elevation. Okay. Looking up, angle of elevation. Looking down, angle of depression. Alright. And here they have a sort of a triangular situation. So there's some person looking at a climber, I guess. So it's a right triangle. We think of this as sort of the horizontal line of sight. So these guys would be parallel. Here's the angle of elevation, and it's 1,000 feet away. I'm assuming they want to know how high, what is the approximate height of the rock climber above the ground. So they want to know what this guy is. Okay, so we have 32 degrees, we have opposite, we have adjacent. So this is SOHCAHTOA. So since I have opposite and adjacent, this is a tangent situation. So this is tangent of 32 degrees, and that equals opposite over adjacent. Multiply both sides by 1,000. So the height of the climber is equal to 1,000 times a tangent of 32 degrees. So that gives me that this guy is 624.87 feet above the ground. And want the approximate height. It's about 625 feet. Here. So the airplane sights a life raft at a 26-degree angle. So plane is looking down at a life raft at a 26-degree angle. I guess there's a river somewhere. River. And there's a life raft. Alright. Airplane's altitude is 3 kilometers. So it's 3 feet off the ground, or 3 kilometers off the ground. It says the angle of depression is 26 degrees. It's looking down. Oh, I'm sorry, that's wrong. 26 out here. Looking down. And the person's line of sight looking up. What is the plane's horizontal distance d from the raft? So the horizontal distance D would be right here. So angle of depression looking down. Vertical height, we have from this angle, can't really do anything, right? So we use alternate interior angles, and we can go down here and say, okay, here's 26. So from this 26, we have opposite and adjacent, so we have another tangent situation. So here we get tangent of 26 degrees goes opposite over adjacent, which is 3 over D. Multiply both sides by D, and then divide both sides by tangent of 26. D equals 3 over tangent of 26. So D equals about 6.15 kilometers. Alright. So the reason why I put the 26 down here is because the angle, here's the line of sight. Right? Here's the angle of depression. I can't do anything from this vantage point, but since I know that they're alternating interior angles, then I can flip the angle and say, okay, if this is 26, then this is also 26. And then I can do it from this vantage point over here. And I have a horizontal, a vertical and a horizontal. So they wanted a horizontal. All right. And guys, that is that section. Hope you have a great rest of your day.